All right, I am back with a video for Chapter 19. Chapter 19, there's really the steps and the work is really going to be the exact same thing that you did in Chapter 17 and 18. As it says here, the rules are going to be exactly the same. The only difference in this chapter is instead of doing confidence intervals and hypothesis testing for percentages or proportions, we're going to be doing confidence intervals hypothesis testing for means. That is quite literally the only difference. So there really aren't any new notes. But just to quickly review, a confidence interval tells us what percent confident we are that the actual percentage is within the interval. And hypothesis testing, remember, that's the one where we do the p-value and we find the p-value, and if it's less than 5%, that means our null hypothesis is false. If it's greater than 5%, then our initial or null hypothesis is true. And whichever one our null hypothesis is, the alternative is the opposite. So if we prove the null to be false, then the alternative is true. If we prove the null hypothesis to be true, then the alternative is false. So that is going to be the same in this chapter. The only difference is instead of going to proportion stats, instead of going to proportion stats, we're going to go, and I put it in bold up here, we're going to go to t-stats on StatCrunch. So again, instead of doing the same steps, only difference is we're going to go to t-stats instead of proportion stats. Okay, and that is quite literally the only difference. So I'll have a couple quick examples here, and then I'll go through the remaining questions in the assignment. So this was an example I took from the textbook. A doctor measured the body temperature of 52 randomly selected patients, and here is the data. Okay, they gave us the sample size, the mean, and the standard deviation. In this case, S stands for standard deviation. So find a 90% confidence interval for mean body temperature of the entire adult population. So you can see I went to t-stats. I followed, and we go back to this. I followed these steps here: stats, t-stats, one sample, and width summary. And I put in the information. So I put in the sample size. I put in the mean, and I put in the standard deviation. I put in confidence level. Notice I put 0.9 for 90%. And this is what I got here. So my 90% confidence interval, if I look at the lower limit and the upper limit, it's going to be 90.1, 98.4. So that means we're 90% confident that the mean body temperature of all people is between 98.1 degrees and 98.4 degrees based on this data. So you can see it's pretty much exactly the same. We just went to t-stats instead of proportion stats. Another quick example here. Let's see. Nabisco claims, this was also taken from the textbook, by the way. Nabisco claims that there are 1,000 chocolate chips in each box of cookies. They counted the number of chips in 16 randomly selected boxes. They found a mean of 1,238 chips and a standard deviation of 94. Is that data evidence that the average number of chips in each bag is actually less than 1,000? Okay. So once again, I put in the sample size was the 16 boxes. I put in the mean. I put in the standard deviation. This time I went to hypothesis test. I noticed I put in 1,000 over here. And the question was, is that data evidence that the average number of chips in each box is actually less than 1,000? So I chose less than here. And I went to compute, and I got a p-value of 1. Okay. So 1 is obviously bigger than 0.05. So let's go back a couple slides here. So this time p-value is greater than 0.05. That means our initial hypothesis is true. So p-value is 1, which is greater than 0.05. That means that the null hypothesis, that means this is true and this is false. This is true. The equals is false. The less than, this is true. Okay, let me start again because I'm getting myself tongue-tied here. Our p-value is 1, which is greater than 5%. Okay, based on the notes from a couple slides back and from chapter 18. That means our null, our initial guess, our initial hypothesis is true, and thus our alternative is false. So we're saying that this, the equals, is true, and the alternative is false. So this part of it being less than 1,000 is false. So to answer the question, is this evidence that the average number of chips is less than 1,000? The answer would be no. Okay, because we proved that this is false. So the data is not evidence that average number of chips in each box is less than 1,000. And that's it for the PowerPoint. I wasn't lying when I said there really wasn't that much new. So I'll go to the Math Excel assignment now. And let's see, I've already done the first 6 questions. So chapter 19 is 7 through 10. So I'm going to quickly go through those questions. Chapter 19 assignment. So I will go through chapters 7 through 10 for you, right? Questions 7 through 10. Let's see. 7. Here we go. So after surveying students at a local college, a campus organization calculated that a 95% confidence interval for the mean cost of food for one term is this right here. How should the organization interpret the confidence interval? So if we go back here, okay, we are blank. In this case, we are 95% confident that the actual, in this case, the instead of the actual proportion, in this case, the actual mean is within that interval. So in this context, that would mean that we're 95% confident, or we're 95% sure that the average cost of food, okay, is between this and this. So which one says that? Okay, to me it looks like C. The organization is 95% sure that the average amount a student pays for food is between $1,097 and $1,319. That's exactly what I said. So the answer is C. Okay. Hoping to lure more shoppers downtown, a city builds a new public parking garage in the central business district. The city plans to pay for the structure through parking fees. For a random sample of 45 weekdays, daily fees collected averaged $126 with a standard deviation of $18. Find a 90% confidence interval. I'm going to go T-stats on this one. So on StatCrunch, let's open StatCrunch. And we're going to go stat, T-stats, one sample with summary. So again, T-stats, one sample with summary. And let's see, what's our mean was $126. Our standard deviation was $18. Our sample size for a random sample of 45 weekdays. And we want to do a 90% confidence interval. So I'm going to change that to 0.9. And there's our answer. And let's see, it says round to 2. So it's going to be 121.49. And the upper limit is going to be 130.9. 0.51. And that should be it. There we go. Number 9. Let's see. It looks like we're doing the same thing. We're doing a 90% confidence interval. Exact same thing. Now, I noted this in the PowerPoint in case you forgot. Let me go back to this. One sample with summary. But the N value here, that is your sample size. So 72 is the sample size. The number with the bar over it, that's going to be the mean. So that's 80.1389. 80.1389. Whoops, put that in the wrong spots. 80.1389. And then this one right here is the standard deviation. So that's 2.27889. And I believe we're doing a 90% confidence interval again. So let's change that to 0.9. Let's compute it. And we got our answer right here. So our lower limit's going to be 79.69. And our upper limit's going to be 80.59. Did I round that correctly? Yes, I did. Okay. So that was number 9. Number 10. Let's see. Company with a large fleet of cars hopes to keep gasoline costs down and sets a goal of attaining a fleet average of at least 26 miles per gallon. See if the goal is being met. They check the gasoline usage for 60 company trips chosen at random, finding a mean of 25.26 mpgs and a standard deviation of 5.39 mpgs. Is this strong evidence that the actual average gas mileage is lower than the goal? And once again, we're going to do T-stats. So T-stats, one sample with summary. Let's double check here. What was our mean? Our mean was 25.26. Standard deviation was 5.39. Let's see. Our sample size was 60. And let's see. For our hypothesis test, our goal was 26 miles per gallon. And they're asking us if is this evidence that the MPGs is lower than its goal. So we're going to make that a less than. And we're just looking for the p-value. There's our p-value. 0.146. And up here, we said that it was less than. Okay? So our hypothesis is less than, and we already found our p-value over here. 0.146. That is it for the question. Okay. And that is it for the assignment. So just a reminder, make sure you email me or you can send me a Google Voice text message. You could send me a Google chat and ask me any questions that you have based on these 3 chapters. Thanks.